Okay, we've seen the parallelograms, we've had some practice on their properties. Now we're going to switch the question on you. Instead of telling you you have a parallelogram, your job is to decide if you have a parallelogram. So that's the converse. You remember the converse is where we're just switching stuff around, switching our if and our thens. So with this, you're in your whisk packet and you've got the theorems that we looked at yesterday listed, but next to those you're going to write down the converses of those. These are the tests for parallelograms. Let's start with our first one. We know that if a quadrilateral is a parallelogram, then those consecutive angles are going to be supplementary. So I want you to switch that around. And the converse says that in a quadrilateral, if an angle is supplementary to both of its consecutive angles, then it's for sure a parallelogram. Pause the video probably here and write that down, then we'll talk about it. Okay, so get a little sketch here. Let's say you got a quadrilateral. All you know is it has the four sides. You want to know if those sides are running parallel to each other? Take a look at their angles. If this angle, for example, right here, let's say this is an 80-degree angle. And I want to see consecutive ones. So I want to see this one next to it, but I want to see both of them next to it being supplementary to this 80 degrees. So if I see this as 100 degrees, then yeah, those are supplementary. I also need to see it right over here. I need to see this as 100 degrees. So that 80 is supplementary to both of the angles that come next to it. Then I know that it's a parallelogram. All right, our converse number 2. Our original said that if a quadrilateral is a parallelogram, then its opposite angles are going to be congruent. So when we switch that around, it reads this way. In a quadrilateral, if both pair of opposite angles are congruent, then it's a parallelogram. Pause the video, write it down. All right, let's add a picture to this one too. You're looking at a four-sided figure. You know nothing about it except, oh, they maybe tell you something about both sets of opposite angles. So you see that you've got a pair of angles that are opposite each other and marked congruent. Is that enough to say it's a parallelogram? Not at all. These two angles could be doing other stuff. But if you have them both, and so you see tick marks showing this set of opposite angles as well as the first set, then you know it's a parallelogram. All right, our next one. Our original theorem said that if a quadrilateral is a parallelogram, opposite sides are congruent. Flip it. In a quadrilateral, if both pair of opposite sides are congruent, it's a parallelogram. This isn't too tough, is it? Okay, so again, you're going to be seeing a picture, a four-sided figure, and maybe some tick marks. One side is the same as another, opposite it. If you see it on both sides, you can say it's a parallelogram. Make sure you see it on both. Next one was about the diagonals. Our original was if a quadrilateral is a parallelogram, its diagonals will bisect each other. You might be able to guess what this is going to say. In a quadrilateral, if the diagonals bisect each other, then it is a parallelogram. Pause the video and write it down. Here's our picture. You have a quadrilateral. You see one diagonal. You see diagonal number 2. Is it a parallelogram? Not so fast. Do those diagonals bisect each other? The only way I would know is if I saw some tick marks or maybe some numbers that tell me that these are equal here. So if I was looking at numbers, then I might see like this is 8. This better be 8. If this here is 10, this guy better be 10. That kind of stuff. Then it's a parallelogram. Now, this is a bonus theorem. If you look at all the theorems we have so far, we had to have 2 pieces of information. So maybe if we had one pair of sides that was both parallel and congruent, maybe that's a parallelogram. It turns out it is. We'll prove that in just a second here, but let's mark what that would look like. So that would mean that you just take one pair, maybe the left side and the right side, or I got more room here on top and bottom. I'll mark those. And that pair of sides is parallel. So you would see some arrows or some indication that these are running alongside each other. But that same pair is also congruent. So a tick mark as well. It's going to turn out that those are going to force the whole thing to be a parallelogram. Let's just look at a quick proof of that. Here's what's going on. I'm going to draw in the diagonal right here. The reason I'm drawing that in is because it splits it into 2 triangles. And if I could just show these triangles are congruent, I think I can show they're parallel. The sides are parallel. So We've already got this side and matching this one. These are parallel. What do you remember about parallel lines? Again, I tell you, back to Unit 3. Let me highlight those parallel lines. So we've got this line and this line, top and bottom here. Those are parallel. That's a given. We draw this diagonal in as it's transversal. Then, yeah, you got this. That means these angles are congruent. Why? What's that Z called? Those Z angles? Alternate interior angles are congruent on parallel lines. And then, oh, we can't miss this. Don't miss the easy stuff. We got the reflexive property on that shared side. So these two triangles, are they congruent? I see side, angle, side, shortcut. Side, angle, side. Yep, they are. If those triangles are congruent, then these corresponding parts are congruent. I want to look at these two angles because corresponding parts of congruent triangles are congruent. And if those guys are congruent, let me get my green highlighter, then that means that this side and this side, the left and the right, they have to be parallel. Why? See the green Z? Those would be alternate interior angles, so, and they're congruent, therefore these guys on the sides are parallel. Okay, there's your proof. And so we got all these theorems. Let's go through the list one more time. Check them off. If you need to prove that a quadrilateral is a parallelogram, you can do it any of these ways. You could just go straight for the definition, just show that you have two pair of parallel sides. Or, if that's too tough, maybe the opposite sides. Show that both pair of opposite sides are congruent. That doesn't work for you? How about both pair of opposite angles? Both pair are congruent. You got a parallelogram. Or maybe you just got one angle and you know it's consecutive angles that they're supplementary. That'll do it. The diagonals, if they're bisectors to each other. Or our bonus theorem, if one pair of sides is parallel and also congruent, you got a parallelogram. All right, so here are some examples. We are given some information. Is it enough to determine that it is a parallelogram? And of course, we must explain. So we're looking for one of these reasons up here. Let's see what we can do with this. Alrighty, first one. Look at that. Opposite sides. They're a match. Two of them. Yes. This is a yes. And I'm going to just explain with my theorem. The opposite sides are congruent. How about here? These are the diagonals. Got a bisector? Yep, these guys match. On the other one, these guys match. That's a yes also. And the reason, diagonals bisect each other. Okay, how about here? What's going on here? We got congruent angles. Congruent angles, these are here in the middle though. These vertical angles are congruent. That's always true. It doesn't have anything to do with these sides parallel. So this doesn't tell me anything. We'll just put a big old no, a smiley, or a frowny face because they're fun to draw. Okay. More examples. Let's see what we got going on here. Oh, these are next to each other. Look at this 60. See how it's consecutive angles? Do they add to 180? Yes, indeed. Both sets adds to 180 this way also. This is a yes. The consecutive angles are supplementary. I don't know a good abbreviation for consecutive. Consecutive angles are supplementary. Okay, I'm seeing some tick marks. I've got a pair of opposite sides congruent here. This guy's a diagonal. I need more. This isn't doing it for me. This is a no. Sorry, man. And last, all right, I see these arrows. Do you see the arrows? These are parallel. And not only are they parallel, they're both 6 units long. They're also congruent. Let me tick mark it. This is a yes for our bonus theorem. One set, one pair is both parallel and congruent. This looks like a creepy face looking at me with some eyebrows. Here's a smile for it. Last example, we're going to show what values of x and y would make flip a parallelogram. This is just a sneaky way to get you to do some algebra. You know that. All right, if flip's going to be a parallelogram and these are sides, these sides have to be congruent to each other. So I need to see this guy matching here. I need to see these guys as a match also. So let's take that x. Let's say the 3x plus 6 side. That has to match and be equal to the opposite side of y plus 4. That's going to be a little bit of a challenge, having x and y both in that equation. Let's see. I'm going to push pause here on that one for a minute. This will be my pause button. We'll come back to that. Let's look at the other set. The 2y plus 2. That side needs to be equal to 3y minus 9. That one I think we can do. So 2y plus 2, set it equal to 3y minus 9. Has to be if this is a parallelogram. We'll solve for y. Okay, what do you say we subtract the 2y from both sides? Yeah! Haven't seen the ninjas in a while. Those canceled. And let's add. Let's add the 9 so we can get rid of it from this side. Yeah! I love that. Okay, back to business. What are we up to here? We've got 11. 11 on this side, and 3y minus 2y is just y. We got 11 for y. Okay, now how's that going to help us get x? Well, we know y is 11. If we come to the picture, this is 11. So 11 plus 4. Let's make this side just say 15. And then in our equation over here, we can make this say 15. We're ready to push play again. Hit the play button. Alrighty, here we go. So 3x plus 6 equals 15. I am going to subtract the 6 from both sides and cancel it there. 3x equals 9. Dividing by 3, I got my value of x. X needs to be 3. So x is 3, y is 11. If that's the case, flip is a parallelogram. You know what to do next. Your turn.